Hello everyone, we're going to talk about negative slope. This is the second part. And I decided to accommodate some of you people because I know a lot of you did not watch all my math videos, and you should have. But since you didn't, this is the Cartesian coordinate system. Now, I'm not going to go into Cartesian. You can look him up for yourself. If you don't, you're just missing out, okay? Now, we have the Cartesian coordinate system. As you can see here, we have two number lines. This is the horizontal number line. This is the vertical number line. As you can see here, we go positive 1. This is 0 right here. Well, these two lines intersect, that's 0. This is positive 1, positive 2, positive 3, so on and so forth, all the way straight down the line. And this is represented by the letter X. Letter X. Now, we have positive 1, positive 2, positive 3, so on and so forth up the line. And this one's represented by the letter Y. Okay? So, anytime you're talking about a vertical line here, that's represented by Y. Anytime you're talking about a horizontal line here, that's represented by X. Okay. Now, how do you plot points? Well, simple. Let's say we have the points 2 and 3. We go 2 spaces over like this, positive 1, positive 2. 3 spaces like this, positive 1, positive 2, positive 3, and we plot a point. We got 2 points, 4 and 9. 1, 2, 3, 4. 1, 2, 3, all the way up to 9. Plot another point. If we were to draw the line would go in an upwards direction, and therefore it'd be a positive slope. Now then, now that I've discussed all that, I'm going to go ahead and put these books up here because I'm going to illustrate the rest of this, because we still haven't quite answered the question, can you have a negative slope and yet have a positive distance? The answer, of course, is yes. The real question is, why? Alright, I'm going to shift my little camera like this. Hopefully it won't fall down. There! Ta-da! Okay. Now then, what is slope? Okay, each set of coordinates has a position on the y-axis and on the x-axis. I showed you that just a minute ago. Okay, you go a certain number of distance to the right for your x-axis, you go a certain number of distance up for your y-axis. Okay, now we use subscripts. I talked about superscripts and subscripts in a previous video. If you do not know what I'm talking about, you need to go back to that video. Okay? And with this video, you may have to go back to quite a few videos, especially if you guys have not been watching me carefully. Alright. Now then, what's the distance formula? Well, that was covered in Euclid Book 1, proposition number 47. If you don't know what I'm talking about, you need to go back to Euclid Book 1, proposition number 47 and learn all those videos. Because if you don't, you're cheating yourself. It's that simple. And I'm not going to go through the whole mishmash again. I put it there. You need to go back in the story. Alright. Now then, let's talk about Euclid Book 1, proposition number 47 for just a brief second here. A squared plus b squared equals c squared. Okay, now this also involves the distance formula. The angle, see, this is on the x-axis right here. This is on the x-axis right here. This line right here. The angle of this line in accordance to the x-axis is what we're looking for in slope. Okay, so we're looking for a numerical value that takes this above the x-axis to a certain point. So, can you have a negative slope? Yes, you can. Alright, how do we find this angle right here? Okay. We use y2 minus y1. y2 is a number with a subscript. And I remember I told you to watch that video about subscripts? Okay. y1 is the same thing. Now, you're going to have y2 minus y1. You're going to get a total here. Now, let's say we have 9 here, we have 3 here. Well, 9 minus 3 is, of course, 6. Then you have x2 minus x1. Well, this 2 and this 1 here are subscripts. Okay, so you have 4, you subtract 2, and you get 2. So, you have 6 over 2, and when you have 6 over 2, you have 3 over 1, which means the slope is 3. Okay, so that just happens to be a positive slope. So anytime the slope goes in this kind of an upwards direction, that's a positive slope. Now, they always describe slope as rise over run. Well, you are rising like this, that's the rise part of it, and you are running across the horizon. Let me tell you something. When you are on an ordinary street, or say you're at a park and you're running down like a paved gravel road or something like that, I don't care where, you could be running in the grass for all I care. If you look off to either side, you're going to see the horizon. If you don't, you're blind and you shouldn't be running anyway. Anyway, if you see the horizon, that's the x-axis. Okay, so, once again, slope is rise over run. Alright, so this number will tell you how far up from the x-axis you have to be in order to get this slope line. Now, that contrasts with the distance formula here. Okay, so you have x2 minus x1 squared. Well, you have a point that's x1, you have a point that's x2, and I know it's way up here, but we can draw it straight down here. Okay, so x2 minus x1 gives you the distance of this line right here. And then you have y2 minus y1. y2 up here, y1 down here. This minus this gives you the distance right here. Okay? And if you have a squared and b squared, which that's, if you're finding the distance here and the distance here, that's what you're going to have. Well, this plus this gives you this, and if you square root that, then you'll have the distance from here to here. Now, distance is always positive. Do you run a negative 5 miles an hour? Of course not. That would be silly. But I know some people are like, oh, you run a negative 5 miles an hour. Bull. Come on. So your distance will always be positive, even if your slope is negative. But there's something else you should have noticed right off the bat. Did anybody watch my trigonometry videos? Probably not. And they should have. Why? Because this ratio right here. What is this? This is opposite over adjacent. Okay? This line here is adjacent to this line here. This line here is opposite of this. Okay? So what is opposite over adjacent? Well, if you watch my trigonomic videos, you would know that's a tangent. This line here, whether it be positive or negative, is a tangent line. Whoa! Bet you didn't know that. Okay, so how can slope be negative? Start throwing in negative coordinates and watch what happens. Okay. 9 minus negative 2 will actually come out to be 11. Alright? And 4 minus negative 3 will come out to be 1. So you'll have 11 over 1, which is 11, which your slope is going to be 11, which in this case would be positive. But if you were to do negative 2 minus 4, okay, then you would have negative 6. Okay, negative 2 minus 4 is negative 6. And negative 3 minus 9 is negative 12. And I think I may have done some bad calculations a minute ago. If I did, then I'm sorry. But you end up with negative 12 over negative 6, which ends up being 1/2. Okay, that's a negative 1/2. So you're going to have a negative slope. But your distance is always going to be positive. Why? Okay? We have this point up here. It is 9 spaces from the horizontal on your Cartesian coordinate system. 9 spaces up. But this other point here is -3. It is 3 spaces below the Cartesian coordinates. All right. Now, we've established that y2 is the distance from the horizon. Okay, this is not necessarily the horizon anymore. It's from the horizon up to 9. Okay, so that's y2. But what about y1? Well, you can't say that y1 is a -3 distance because you can't walk a -3 feet. You can either walk 3 feet or none at all. Okay, so you're actually going to say 3. Okay, so what we're going to do is we're going to change that -3 to a +3, and therefore 9 plus 3 equals 12. Okay, because what you're going to do is you're going to add y2 and y1 together. Because y1 is an additional distance beyond y2. Okay, so 9 plus 3 gives you 12. Otherwise, you get 6. And if you do that, well, it's going to get screwed up pretty quick. Same thing here. You have a +4 on the x-axis, but remember you have an additional distance back behind the x-axis. Okay, you have a -2. But we're not going to take that as a -2. We're going to take that as a +2 because you're actually walking 2 extra feet. Even though it's in the negative direction, you're still walking 2 physical feet. So 4 plus 2 equals 6. And 12 minus 6 still gives you the 1/2 whatever. And I can go on and on, but I think you're finally getting to see the point here. The point is that if you have negative coordinates like this, you have to turn them into positives in order for this equation to work. And instead of saying y2 minus y1, you'll say y2 plus y1, because y1 will be an additional distance beyond y2. Okay, remember, y2 is only measured from the point to the point on the horizontal axis, which is 0. And that's pretty much all I've got to say about this. If you're a little bit confused, let me know. Keep in mind that the slope formula here is tangent. That's right, the slope formula is a tangent, and you can use this tangent to find your slope, whether it be positive or negative. And if you change these numbers here from negative to positive, you can find your distance formula. But of course you'll have to change your signs in here as well, because it's no longer x2 minus x1. Okay, it's x2 plus x1, and it's y2 plus y1. Why? Because you're adding an additional distance beyond the number line. Alright, hopefully that didn't confuse you too much. I will tell you more in the next video, so stay tuned.